Right, good afternoon guys. Today, remember here, so today we are going to have an introduction to what we call ICAP SPICE simulation. So it's of course in the family of the SPICE simulators. SPICE just stands for simulation program with integrated circuit emphasis. So this is one of them. We've got LT SPICE, we've got P SPICE. So I'm going to use the ICAP one, which is ICAP SPICE. It works exactly the same as the other two. So what do we use the software for? Normally it works for if you're doing electronics, right? Analog or digital electronics. If you're doing circuit systems 1 and 2, you can use this software to actually help you or verify your calculations, if I may say, or verify your experimental results. You can use this software. You just build your circuit on this page that I have here, then you actually analyze it. So I'm gonna go through some steps that you might need to help you achieve this. So there's one way of doing it, right? There's this help button up here. This help button, what it does is just, if you do not know what to do at all, you arrive at this software. So you click help. Let's say you want to know how to add components and blah, blah, blah. So you help contents, how to, then it tells you how to place components on the page. But of course, that's not what we're doing today. I'm actually here to do the help for you. So what do you have to do? Oh, of course, you have to have the ICAP on you. You have to download it. You can use it. Well, just a pointer. It works both on MacBook and Windows, but I would actually recommend to use it on Windows, right? It works better on Windows. It's easier on Windows. On MacBook, or if you can actually have an interface, Windows interface in your MacBook, then you download it and use that. That will be better, right? So then the first thing that you should know is how to add parts, right? So there's one way of doing it by just having shortcuts, right? You can put just O on your keyboard. It gives you a ground. You can put R, it gives you a resistor, but this is not always the best case to go about it. So the best case to go about it, I'm going to tell you step by step, right? You always have these tabs. There's file, edit, parts, options, subdrawings, actions, blah, blah, blah. So if you go to parts, if you just click on parts, you have this drop down menu. So on this drop down menu, if you go to X parts browser, so X parts browser, it gives you a platform or a pool of the parts, all the parts that you can find in the software. They are found here. Not that you cannot add your own. You can always add your own if you have, that is only if you have all the characteristics, okay, or of your component that you want to add. So you can add, some need the saturation current, some need activation voltage, some need bias voltage. So you need to add those by yourself, right? But this is one way you can find CMOS. That you go to buffers, BJT, bipolar junction transistors, MOSFETs, okay, complementary metal oxide semiconductors, few defect transistors. You know, you can add as much as you want, right? But that's not what I want to do. I just want to help you add a simple circuit. So adding a simple circuit, you can go to parts again. So in parts, I'll just point this out now. Ground, this ground tab I'm on right now, it's very important, right? Whenever you build a circuit, make sure you have to ground your circuit. If you do not ground your circuit, you're risking two things. One thing is it won't run. The circuit won't run at all. That's one. Two, it might run, but it will give you incorrect results because it does not have a reference. So it will just assume any reference point for itself. Then from there it runs taking that point as a reference, which will give you incorrect results. So always ground your circuit. That's point number one. Then of course, if you want to put test points, I'll explain more about what a test point is. Then we can put a voltage source. Of course, your circuit has to have a source. You can put a current source, whatever you want to put, right? Then when you want to add components, actual components, right? These are shortcuts to adding components. So you have got passive and active circuit components. So passive circuit components are like resistor, inductor, capacitor, you know, all those components that you can just connect on a breadboard without need of any bias voltage or activation voltage, right? Those components like a resistor, right? This one is a resistor I'm having here. It's a 1K resistor, brown, black, red. What do I mean? It does not need any activation voltage. What I mean is, if you can just put it on a breadboard, okay, this is a breadboard, you can just put it on a breadboard like this, then straight away connect right? Connect voltages, whatever. It does not need any activation, then it works straight away, right? But that is a different case when you go to active circuit components. Active circuit components, for example, they are diodes, BJTs, diodes need forward voltage. Before that, it's a semiconductor. Before maybe 0.6 or 0.7 volts, it does not work. After that, then it switches on, then it works, right? And MOSFETs, or you go to op-amps, right? Like this is an op-amp I'm holding here, operational amplifier. So this is a 741 operational amplifier. It has got legs. If you can see, there's some legs there, about 8 of them. So on these legs, right, they are bias voltage legs, should be pin number 4 and pin number 7. One has to have plus 12 or to 16 volts. The other one has to have minus 12 to minus 16 volts. So those two legs have to be connected and they have to be biased. You have to put that voltage first. Once you put that voltage, then the op-amp can operate. If you do not put that voltage, no matter how much you connect it correctly or with whatever, making pin 6 output, pin whatever input, no matter how much you connect, it will not work as an amplifier or whatever you're trying to use it for, right? It needs that voltage to work. So those are active circuit components. Sorry. So what I'm going to do right now, I'm just going to build a simple circuit that have 2 resistors and a voltage source, right? Then I do an analysis using that, right? So I'll just go to passive circuit components. I add a resistor. So, you see, once you click resistor, it comes here, right? So you can move it wherever you want. I'll just put this resistor here, right? For now, I'm just going to place it there. You can duplicate it if you want, but I'm just going to go the long way. Then I put another resistor. I have it here, right? You can double click it. Then it highlights the resistor. Then you can drag it as much as you want. You can rotate, right? For it to be in the orientation that you want. So I'm just going to rotate this way, right? Then I'm going to add a voltage source. I'm just going to parts again. Then I have voltage source. I'll just add a voltage source. I'm going to put it somewhere here. Right. So, guys, maybe you cannot see, but I have grid lines that are actually guiding me where to put these components, right? You can either choose to put them or not put them. That's up to you, right? I prefer the grids to be there so that I don't just place the components anywhere else, right? So I can build sort of a cleaner circuit, right? Then, of course, like what I said, always very important. I put a ground, right? I'll just put it anyway, right? Then now I have my circuit components, right? These are just components added. They're not connected to each other. So what do I have to do? I have to take a wire, right? I have to take a wire. So wire, I'll get it from here. This end, the first one is just a pointer, right? The second one, it says wire or bus 2. So I just click on that. If I click on that, I get a pen. So this pen becomes my wire connector. So I'll just follow from here to here, then from there to there, then from there to there, then from there to this one, from this resistor to this, then I'll just go straight to this voltage source. Then I'll connect my ground, right? Then, of course, I have to remove this wire. Now I don't have it. So, right, one thing, when you're building a circuit, as you can see on my circuit, I don't know if you can see, let me just, for you to see a little bit. On my circuit, here, I'm having a red diamond. Here, I'm having another red diamond. This means there might not be a connection, or there might be a wire that's crossing, right? It passed where the resistor is supposed to end. So this is a wrong connection. It might give me problems or wrong results. That's one thing. 2, when you see there are these numbers, 1 here, 2 here. What this means, it means my circuit is already reading this as node number 1, this whole node, and this as node number 2. Of course, I do not have any number here because this is just a ground node, right? So node number 1 and node number 2. That's what my circuit is on right now, right? Okay, now I continue. So the first thing, I need to remove those diamonds, right? So I'll just double click on it. I need to just highlight this, right? Okay, then it gives us more highlights. All you just have to do is press delete. It removes that diamond. See, I don't have it anymore. So I do the same here, right? Just make sure you click on that diamond exactly. It gives you this node number 1, node for this name. You don't want to name the node. Just say, okay, it highlights this point. Just press delete. It removes that diamond. Now, see, My circuit is now clean. It does not have those diamonds, right? It's now clean. So now what's left? I need to add the resistor values. I need to add the voltage value, whether I'm going to use DC voltage, AC voltage, you know, all those things, right? So that's what I'm going to do. So I'm going to name this R1. So you just double click on the resistor, double click, it gives you all these values. So what do you just go, you go to value, you add the value that you want. So in this one, I want to add, to make it 6 kilo ohms. So I just write 6K. If you just write 6K like this, yeah, if you write 6K like this, it will just know that you mean 6,000 ohms, right? Then you say, okay. So there are two things. If you say, okay, you can see it's already showing here, 6K, R1 is now 6K, right? So sometimes you might face a problem and you don't see it being displayed, right? Or see the number or the value of the resistor being displayed. That will mean this one, because you can have an option to remove this one. See what happens. See, my 6K is no longer showing. So if you want it to show on your circuit, always have this value, click on the value and say add. It adds it, then you say, okay, now it adds the value. So you do this for all the components. On this one, I'm just gonna have it as 4K for now, which means 4,000 ohms, right? Then I just say, okay. Then I go to my voltage source. So my voltage source, right? Simple analysis, I just want to add, to make it whatever voltage I can give, maybe 12 volts for that for now, right? So all you have to do is just double click on the voltage source and go to where it writes DC, right? Then I'm going to write 12. Let me remove that, right? 12 volts. Right, I'm going to write 12 volts and I say okay. It's not being shown, right? As you can see, it's not being shown. So what do I have to do? I have to do what I did at that point, whereby I write add, right? If I want it to be shown. So on the 12V, I say add, right? So it adds it here. Then I say, okay, now I can see 12 volts is coming in. Oh, we got a visitor, small fly. Fine. Yeah. So now that becomes my circuit, right? Simple circuit, 2 resistors in series with a voltage source, right? Now, let's see on how now to run the circuit. I have finished this, yeah? This is perfect. I have my ground, I have everything I want. It's perfect, right? Then there's always this question. I've been faced with this question where there's this test point, right? I can either add a test point or choose not to add a test point. What is a test point? Okay, in this case, I'm just gonna put it so that we all see what it is, right? I'm just gonna connect it here, right? A test point, it's nothing but just like, instead, look. Instead on the breadboard, right? The breadboard is like this, right? Then there's that resistor on the breadboard. Instead of you actually taking a measurement directly on where the resistor is, like connecting maybe a crocodile cable or whatever on the resistor, I'm telling you to add a cable so you can connect the crocodile cable at the end of that white cable. You see? So that's a test point. I'm just saying you're gonna use that node or that at the end of the cable to actually record. That's it. So that's a test point. So it's nothing complicated, but for now, let me just put it, right? Then we need to run this circuit. Right, so before we run the circuit, before you do anything, the circuit will never run, ever run if you do not save. So you need to save it. So you can just click save and yeah, I mean, save anything. Let's just say, what's this? Spice tutorial. Yeah, Spice tutorial. Let me just save it like that. Yeah. Okay, it has been saved, right? Now that it has been saved, what we need to do is to know how to run this circuit, right? So we go to options. Okay, we go to actions. Then we need to set up a simulation, the type of simulation that we want to run. Okay, I'll explain further what this means. Then you go to edit. You click edit. So now what I mean by the type of simulation that we need to do. So as you can see here, it's written analysis, right? Yeah, plural of analysis. analysis. So it means we have got different sorts of analysis that we can actually do on a circuit. We can do a DC sweep, we can do an IC analysis, a transient analysis, operating point, noise, distortion, blah, blah, blah. Let me explain, right, what this stands for. So AC analysis, I'm just saying that's where you input a signal, you give your own signal, be it triangular wave, sinusoidal wave, square wave, you give the input, you give the amplitude, you give the frequency period, whatever, then you let a circuit run, right, given this input voltage that you are given, right, and analyze the output, right. Then you go to the DC sweep. So DC sweep is like you're connecting a DC voltage, right. Then instead of running a DC voltage, giving input 1 volt, checking what the output is, 2 volts, checking what the output is, 3 volts, you are actually just sweeping maybe from 0 to 5 volts in steps of, you can say 0.01 volts. So you want to analyze the behavior of this circuit in steps of 0.01 volts. So it's dependent, right? It's dependent on the voltage. So the voltage, the steps are voltage steps. So you're saying at every 0.01 volts, how is my circuit going to behave? Right? That's a DC sweep. You are sweeping, let's say, from 0 to 5 volts, but in increments of 0.01 volts. You want to see the behavior of a circuit in these time steps or voltage steps, let me say. That's a DC sweep. Now, if you do a transient analysis, is you want to see the behavior of your circuit, right, from 0 volts from the start point to the steady state, right? Right. So it means the difference between this is that in transient analysis, you are checking the behavior of your circuit with respect to time. Not with respect to voltage as in DC sweep. So with respect to time, you want to see, you can set this, maybe your circuit stabilizes in 0.1 microseconds. So you want to see what happens from 0 to 0.1 maybe milliseconds, let me say, or 0 to 1 milliseconds in time steps of 0.1 microseconds. You want to check what happens at 1 times 10 to the minus 6 seconds every 1 to 10 to the minus 6 seconds until I reach 1 times 10 to the minus 3, until I reach 1 millisecond. What happens is that when my circuit actually stabilizes, right? That is transient analysis. Then operating point, which I'm going to choose for this first part. Operating point is just, okay, fine. I just put my 12 volts, put my 2 resistors, then let the circuit just run as it wants, as it wishes. Then I just check the output voltages. I just check, is it the correct input voltage coming in or the correct output voltage drop across this resistor or across this resistor. So I'm just checking the circuit on its own, right? Then noise is whereby you actually, because noise, as it might seem, noise is actually a signal on its own. So we can define our own noise, then put this noise in a cable, right? Inject this noise in a cable. Then using this noise that we have input, right, we check the strength of this cable, or how much noise can this cable withstand depending on where we want to use it, right? Maybe this line we want to use it on top of the railroad line, or we want to use it where many signals are going to be crossing. So we need to see how much noise it can withstand, right? So we can input noise as much as you can. So this is the noise. Then there's Fourier transform, DC transfer functions. See, transforms, if you go into signal and systems now, you can find Fourier transforms. You can actually analyze the circuit analysis using Fourier transform. So yeah, these are different sorts of analysis. But what analysis I'm going to pick for this circuit that we built, it's the operating point analysis. So I can choose whether to show all the node voltages, the source currents, or device of operation point and all model parameter information. I can choose whatever I want. Then I say, okay, right? Then on that note, I can choose to remove the simulator options, right? Does not really affect my circuit. Then I say done.